Hi guys, Mr. Anderson here for Science Lab 7, and today we're going to be talking about the Earth, right? But not just the Earth, we're going to be talking about earthquakes and studying earthquakes. Now remember, previously we looked at different instruments we used to study earthquakes, and one of them that we talked about was a seismograph, right? And it measures not only how much shaking there was, but also when that shaking occurred, which is really amazing. And it spits out a recording of that shaking that we call a seismogram. And the people that read that, people that study that, we call those seismologists. Seismologists. So here's the thing. We're going to be looking at people and earthquakes and how earthquakes affect people. All right? So here's the thing. One of the good things about earthquakes, oftentimes when we think about earthquakes, it's always about the bad stuff. But one of the good things about earthquakes is that without earthquakes, we wouldn't know much about the interior of the Earth. So that's a good thing. So some things I think we would consider not so good or bad things about earthquakes is that there's loss of life, and there's destruction of property, right? Earthquakes cause billions of dollars of damage every year. So we as people, and when we interact with earthquakes, right, one of the things we like to do is we like to measure them, right? We like to measure earthquakes, and we have a couple different scales that we use to measure earthquakes. Now, one of those scales that you're probably used to is something called the Richter Scale. Right, the Richter scale. Now, the Richter scale is a measurement of the magnitude of an earthquake by calculating the seismic energy. Now, that word magnitude means a measure. In this case, it's a measure of the energy released by an earthquake. We talk about an earthquake's magnitude. We're talking about how much energy was released by that earthquake. And again, the Richter scale measures the magnitude of an earthquake, how much energy was released by an earthquake, right? The Richter scale is not worried about, hey, how much damage was done? Did your house fall on you? Or anything? That's not worried about that. The Richter scale just wants to know, hey, how much energy was released? And then it gives it a number. Now, technically, there's no upper limit to the Richter scale. If there's more energy released, then it's going to be a bigger number. Now, most earthquakes are too low to be felt. Most people don't even realize that earthquakes are happening. We know they happen because we have very sensitive instruments. But in general, most earthquakes are too low to be felt. The largest earthquake ever recorded was in 1960 in Chile. It was a 9.5. But 55,000 earthquakes happen every year that are between a 3 and a 4.9. 55,000 a year. And thousands of earthquakes happen every single day that are so low that nobody feels them. Now that's amazing. Our Earth is an active place. Now there's another scale that we use to measure earthquakes, and that scale is called the Mercalli Scale. Now the Mercalli Scale measures the seismic intensity of an earthquake by looking at the effects, by rating the effects of that earthquake, and how much damage is done at different sites. The idea is that the closer you are to the earthquake, the more damage is going to be done. And so for the Mercalli Scale, someone from the USGS might call up different locations in the area and say, oh, what happened during that earthquake? And someone might say, well, I don't know, it's just, we were kind of sitting there and the lamp was kind of swaying back and forth. But other than that, it wasn't a big deal. And so based on that account, they might give it a number. Or they might call up a different town and say, hey, what was happening during that earthquake? And someone in that town might say, oh, it was pretty scary. There's a big crack now in my wall. Oh, and then based on that account, they could give them a Mercalli number. Okay? And again, with the idea that the more damage it's done, the closer that you are to that earthquake, you can get an idea of about where that earthquake began. How much damage occurs in a location depends on four things. The first thing that's a factor when looking at how much damage is done is the strength of the quake, right? The more energy that's released, the stronger the earthquake, the more damage is going to be done. Now, the second thing that affects how much damage is done is the nature of the surface material, meaning what is the ground made of? The more loose the soil, usually that's going to cause more damage. The third thing that affects the damage is the design of the structure, right? Is the structure designed to withstand an earthquake? Then it's probably going to do better. If it's not, then it's probably not going to do so well. And then the fourth and final thing that affects how much damage is done during an earthquake is the distance to the epicenter, right? How close you are to where that earthquake began. If you're right where that earthquake began, chances are there's going to be a lot of damage, right? If you're further away, the further away you are, the less damage you're going to receive from that earthquake. But earthquakes can do other things than just shake and damage things, right? There's something called liquefaction. Now, liquefaction occurs when wet soil acts more like a liquid during an earthquake. It almost has a quicksand effect, right? So it may cause buildings or objects to sink into the ground, which is kind of a scary thing if you think about it, right? Can you imagine being in your home and then all this shaking happens, you're oh my goodness, finally it stopped, and you go to open the door and you just see dirt? Oh my goodness. But also, earthquakes can cause tsunamis. Now again, tsunamis, it's a seismic sea wave. It begins over the earthquake's focus. There's a shift in the ground. Okay, so think in the ocean, you have these two plates and one gets pushed up or dropped down. Okay, and it moves not only that land, that crust, but it also moves the water and begins a wave. And it might not seem like much out in the ocean, but as it reaches shore, those waves can be highly, highly destructive and can reach as high as 30 meters. Can you imagine a building tall of water coming towards you? Tsunamis can be very destructive. So today we've looked at people and earthquakes, right? We measure them. We use different rating scales like the Richter Scale and the Mercalli Scale to rate them. And again, we saw that earthquakes can cause things like liquefaction and tsunamis. Well, this is Mr. Anderson signing off for Science Lab 7 saying, stay curious.